இது போகிறதுக்கு என்ன சார் பண்ணணும்? ஃபுல் ஸ்க்ரீன் வச்சுக்கணுமா? Myself, Dr. Sengolrajan, going to present on the topic vehicle motion and dynamic equations for the vehicle. Here you are having the vehicle motion dynamic setup. The front wheel is the torque produced in the front wheel is represented as T suffix Rf, on the back side is T suffix Rr. The force exerted from the front wheel is represented as T suffix F suffix Tf, on the back side is F suffix Tr. The angle inclined from the back wheel is represented as alpha. The mass body that is acting at the center of the vehicle is represented as M suffix Vg sin alpha, and the another component is MEG. One is MEG sin alpha and the another component is MEG cos alpha. Then the distance between the wheel and the center of the mass body is represented as H suffix G. The length between the center of the point and the front wheel is length is L suffix A. Then the distance between the center of the point and the back wheel is L suffix B. The total length of LA plus LB is represented as FL. The force acting on the front wheel is represented as H suffix F suffix W, moving at a velocity of v. The height between Fw and the surface of the wheel is represented as H suffix W. The tractive effort F suffix T in the contact area between tires of the driven wheels and the road surface propels the vehicle forward. While the vehicle is moving, there is resistance that tries to stop its movement. The resistance usually includes tire rolling resistance, aerodynamic drag, and uphill resistance. To provide time measurements in terms of current time and data as opposed to a counter value, as per Newton's second law, vehicle acceleration can be represented as change in velocity divided by change in time is equal to summation of the forces F suffix T minus summation of the forces F suffix Tr divided by del into M suffix V, where V is vehicle speed, summation of F suffix T is the total tractive effort of the vehicle, summation of F suffix Tr is the total resistance, M suffix V is the total mass of the vehicle, and del is the mass factor, which is an effect of rotating components in the powertrain. Now, vehicle resistance opposing its movement includes the rolling resistance of the tires as rolling resistance torque T suffix Rf and T suffix Rr, aerodynamic drag F suffix W, and grading resistance M suffix V G sin alpha. Rolling resistance, here the force at the center of the point is F and the point P moving at a direction, and here you are having the distance between the surface and the center of the wheel is nothing but R suffix D. Here two diagrams represent. The A represents the deflection and rolling resistance on a hard surface, and the diagram B represents the deflection and the rolling resistance on a soft rolled surface. The movement produced by the upward shift of the resultant ground reaction force is called the rolling resistant movement, as T suffix R equal to P suffix A. To keep the wheel rolling, a force F acting on the center of the wheel is required to balance this rolling resistant movement. This force is expressed as capital F equal to T suffix R divided by R suffix D equal to P suffix A divided by R suffix D equal to capital P into F suffix R, where R suffix D is the effective radius of the tire and F suffix R equal to A divided by R suffix D is called the rolling resistance coefficient. The rolling resistant movement can be replaced equivalently by a horizontal force acting on the wheel center in the opposite direction of the moving of the wheel. The equivalent force is called the rolling resistance with a magnitude F suffix R equal to P into F suffix R, where P is a normal load acting on the center of the rolling wheel. When a vehicle is operated on a slope road, the normal load P should be replaced by the component which is perpendicular to the road surface. F suffix r equal to P into F suffix r cos alpha, where alpha is the road angle. The rolling resistance coefficient of a passenger car on concrete road may be calculated by F suffix r equal to F naught plus Fs into V divided by 100 into 2.5, where V is the vehicle speed in km per hour and F naught and Fs depend on inflation pressure of the tire. Most common range of inflation pressure. The following equation can be used for a passenger car on a concrete road, which is written as F suffix r equal to 0.01 into 1 plus V divided by 100. The equation predicts the value of F suffix r with acceptable accuracy for speeds up to 128 km per hour. Rolling resistance coefficient. Here is the various conditions, and correspondingly rolling resistance coefficient. So for example, when a car tires on concrete or asphalt, the rolling resistance value is 0.013. Car tires on rolled gravel, the rolling coefficient of resistance is 0.02. If it is rolling on tar macadam, it is 0.025. When it is traveling in a field, the rolling resistance is 0.1 to 0.35. Correspondingly, it continues when the wheels on a rail, the coefficient is 0.001 to 0.002. Next, going to aerodynamic drag. The high pressure exerts in the front wheel and the low pressure exerts in the back wheel when the vehicle moves in the forward direction. A vehicle traveling at a particular speed in air encounters a force resisting its motion. This force is represented as aerodynamic drag. Aerodynamic drag results with the two components. One is shape drag and the other one is skin friction. Shape drag is nothing but when a vehicle moving at a forward direction, the air pushes front of it, and the air cannot instantly move out of the way, and its pressure is increases, which results in high air pressure. The air behind the vehicle cannot instantly fill the space left by the forward motion of the vehicle. It creates a zone of low air pressure. The motion therefore created two zones of pressure which opposed the motion of the vehicle by pushing it forward and pulling it backward. The resulting force on the vehicle is the shape drag. Skin friction. Air close to the skin of the vehicle moves almost at the speed of the vehicle, while air far from the vehicle remains still. In between, air molecules move at a wider range of speed. The difference in speed between two air molecules produces a friction that results in the second component of the aerodynamic drag. Aerodynamic drag is a function of vehicle speed v, vehicle frontal area A suffix f, shape of the vehicle, and air density rho. It is represented as capital F suffix W is equal to 1 by 2 rho into A suffix f C into D into V plus V omega the whole square, where C suffix D is the aerodynamic drag coefficient that characterizes the shape of the vehicle and is the component of wind speed on the vehicle moving direction, which has a positive sign when this component is opposite to the vehicle speed and negative sign when it is the same direction as vehicle speed. The next, grading resistance. Here is a picture showing the automobile climbing on a grade. So the force is represented as F suffix G equal to M suffix Vg into sin alpha. Here one component is M suffix Vg sin alpha, other one is MEG cos alpha. Then here are the various vehicle type. For this various vehicle type, there is a corresponding aerodynamic resistance is represented. Then how, if by through using a simple calculation, the road angle alpha is replaced by a grade value. So that is I equal to capital H divided by L is equal to tan alpha, which is approximately equal to sin alpha. The tire rolling resistance and grading resistance together called road resistance, which is represented as F suffix Rd equal to Ff plus Fg equal to MEG Fr cos alpha plus sin alpha, The road angle is small. The road resistance is simplified as F suffix Rd plus Fg equal to Meg into F suffix R plus I. The next dynamic equation. Here is represented the diagram when the vehicle is in motion. Then the rolling resistance of the front and rear tires is F suffix Rf and F suffix Rr. Rolling resistance moment T suffix Rf and T suffix Rr. Aerodynamic drag capital F. Grading resistance Fg, Meg sin alpha, and tractive effort of the front and rear tires F suffix Tf and F suffix Tr. F suffix Tf is 0 for a rear wheel driven vehicle. F suffix Tr is 0 for a front wheel driven vehicle. The dynamic equation of the vehicle motion along the longitudinal direction is represented by m suffix v into dv by dt equal to f suffix trf minus f suffix trf minus f suffix rf plus frr plus f omega plus fg. dv by dt is the linear acceleration of the vehicle along the longitudinal direction, and m suffix v is the vehicle mass. The first term on the right hand side is the total tractive effort and second term is the resistance. Then by adding all the summation of the forces at the point R, the center of the tire ground area, the normal load on the front axle Wf can be represented as Wf equal to Meg Lb cos alpha minus summation of all the forces divided by capital L. Then the maximum tractive effort that the tire ground contact and supported by small amount over this maximum tractive effort will cause the tire to spin on the ground. Here Ft max formula is derived, and finally Ft max equal to mu Meg cos alpha into La plus Fr into Hg minus Rda divided by L whole divided by 1 plus mu Hg by L. Using this expression we can be able to calculate the tire ground cohesion and the driven wheel with spin on the ground leading to vehicle instability. Thank you.